Okay, welcome back to a new section 7.4, which is integration of rational functions by partial fractions. The title of this section needs to be explained. Integration, that we know what the integration is. Now we need to remind you of what is a rational function, and then I need to tell you what is the partial fraction, because we will take rational function and we will use the partial fraction methods. So in short, let me just try to explain rational functions up here. Rational function is usually, it's from the name rational, so it has numerator and it has a denominator, and both the numerator and the denominators are polynomials. So I hope you remember polynomials function. Polynomials function, something like x cubed plus 2x squared plus x minus 1. And it could be anything of this form, x minus 1, it could be x squared plus 2x, and so on. So rational functions are polynomial on the top and polynomial on the bottom, numerator and denominator, and both of them polynomial of those forms. Anything like this, we call it a rational function. And what we want today, our goal is to find the integral of the rational functions. Let's see some example. Look at this one. If you look at this function up here, this is a rational function. Why? Because if you look at the numerator, this is clearly a polynomial. And if you look at the denominator, of course I can expand. And if I expand, what I will get is 3, and then I will get 5x, and then minus x squared, and this is by itself a polynomial. So I will get a polynomial on the top and a polynomial in the bottom. Polynomial over polynomial, we call it rational function. That's what is a rational function is. So we need to do the integration of this one using the idea of partial fractions. Same as this one. Again, here I don't have an x, but the constant, the numbers, again are polynomial, and this one again is a polynomial. Something like this, polynomial over polynomial, we call it rational function. We need to find the integration, and this one as well. So rational functions are polynomial over polynomial, and what we need to do is we need to use the partial fraction method or decomposition to find the integral. Let's see what's the partial fraction decomposition. It's a step. First of all, remember we have a polynomial on the top, polynomial on the bottom. Step number 0, sometimes we don't need to do it. When do we need to do it? We look at the degree, which is the highest power of x in the numerator, and the highest power of x in the denominator. To use partial fraction, we must have the degree here is bigger than the degree is in the top. Now, what happened if the degree in the top, the degree of the numerator, is greater than the degree in the denominator? This is the option step that we will do a long division to make it degree of the denominator is greater than the numerator. This we will see it at the end of this lesson, so we shouldn't worry so much about it. Second step, we need to factor the denominator completely. So if the denominator is x squared plus 4x, we need to factor this one into something with something. Of course, this will be just x, and here x plus 4, but again, we need to factor it as much as we can. Step number 2, we need to do the partial fraction, and we will show you in the example what do we mean by the partial fraction. And if we do partial fraction, we will get something, we call it the constant of the partial fraction, and we need to find them in step number 3. And step number 4, we need to finalize the answer by doing the integration. So those are the steps that we need to do. And let me do it in an example, and I will try to explain it as slow as I can. The first example is find the partial fraction of this function. We see it in the first example. Okay. The first step, you need to tell me what is the degree of the numerator. The degree of the numerator is equal to 1. Now, what is the degree of the denominator? Here we have degree 1, and here we have degree 1. So if we multiply them, the degree will be just 2. Because you multiply x by x, you will get x squared. Now, if the degree of the numerator is less than the degree of the denominator, then we don't need to do the first step, or step number 0. We just need to go to step number 2. And step number 2 was telling me to factor the denominator. And here, the denominator is already factored. I cannot factor this anymore, and I cannot factor this any simpler. So I just need to go to step number 3, and that will be this step. Let's see what step number 3. You take each factor, each bracket, and you write it separately. This is, we call it partial fraction. So 1 plus 2x, and here 3 minus x. And then you put a plus between them. It's like you split them. They are together here, and there is a multiplication. You just change it into a plus. You take each factor and you write it down by itself. Okay. Now the question is, what should I write here? And that depends on this one. What is the degree of this one? What's the degree of this or that? This is degree equal to 1. And usually if the degree is equal to 1, we call it linear factor. If we have a linear factor, all what you need to write is just a constant. It will be a number. It has no x. This should be a number. And we will find this number in a minute, but that's what we should get. We should get a number up here. Now, we ask ourselves, what is the degree of this factor? It is 1. So this is a linear factor. For linear factor, again, we put another constant, and I will just call it a. That's the first step. So you take each factor and you write it separately. And in the top of each one, you just write a constant. You just write a number. Okay. The next step is, so this is step number 2 in our solution. This is step 2. Step 3, find the constants. How do we find the constant? The easiest method, you multiply everything by those two brackets. Do you see them here? Just multiply everything by it. And that will give you the answer. So if you allow me to do it here, I just need more space maybe. Just let me prepare things. 4 plus x over 3 minus x, 1 plus 2x equal to 1 plus 2xa plus 3 minus xb. Okay. And what we need to do now is we need to multiply everything by those. As simple as possible. So I just need to multiply 1 plus 2x, 3 minus x. Same thing here. So basically you multiply everything in the denominator, just to make sure that we don't have any more denominators. Now, if you look at this, all what I did was multiplying everything by this. Write it 3 times here for each one of those. Now there is a cancellation. So we get 4 plus x. There is a cancellation here, and then there is a cancellation here. Let me just do them with a different color. This cancel with this cancel with this one with this one, and this one with this one. So the final answer now, on the left side, you will get just the numerator. Here you will have a times 3 minus x plus b times 1 plus 2x. And that's what we get here. Okay. So that's what we have. And the next step, step number 4, is we need to find how much the value of a, how much the value of b. Now, how can we find the value of a and b? It is very systematic. What I want you to do, choose any number for x and substitute it here in both sides. Okay. Now, when I say choose any number, yes, you can choose any number, 0, 1, -1, it doesn't matter. But the best numbers, which will make this one equal to 0. Which number make this bracket equal to 0? Can you tell me? Exactly, it's a 3. So I would suggest you use a 3. Same thing. Again, you will need to use another x. You have to choose 2 x's. Now, the best x you can choose is which make this one equal to 0. So you have 1 plus 2x equal to 0. So this means x equal minus half. And that x what you need to choose. And you substitute it here. So choose -half and check what you will get. So the first one, I will choose x equal to 3. Please substitute x equal to 3. What do we get in the left side? 4 plus 3, this is 7. If we substitute x equal 3, it will be 3 minus 3, which is 0. 0 times a, which is 0. So this will be 0. So we'll just get b times, if we substitute instead of x 3, I think it will be 7. So times 7. This means b equal to 1. That's the first information that we have. We need to do the same thing, but now for the other number, which make this one equal to 0. We said it is -half. So this one is -half. Now, can you substitute x equal -half here? I think we will get 7 over 2. Just check it with your calculator. If we substitute -half, this will be 0. 0 times b is just 0. Now, if we substitute half here, we get 5 over 2, I believe. Okay. Easy peasy. Your a will be 7 over 5. And that's the 2 answers you will get. So the final answer, 4 plus x, x minus 3, 1 plus 2x, this is equal something plus something, which is x minus 3, 1 plus 2x. What shall we write in the top? Here I write 1, and here I write 7 over 5. And that's exactly where we end up with. This is how we do partial fraction. It's a long process, yes. We need to do the partial fraction. We need to find the constants. But the benefit of this, you will see it in the next example. Let's see the next example, which is I want to do the integration of this one. Do you remember? That was my goal. And to do the integration of this one, I just need to do this which is easy peasy, and I need to do this, which is again easy peasy, because those are very familiar integration, very easy to be done. And that's question number 2 up here. Is evaluate 4 plus x 3 minus x minus 3 dx. How do we evaluate this one? Is easy. Plus x minus 3 1 plus 2x dx equal to, here we use the partial fraction, so we get integral of something plus integral of something else. The first one will be x minus 3, and then I think there was 7 over 5, and the other one was 1 on the top, 1 plus 2x, which is again easy because this is just 7 over 5. The integral of 1 over x minus 3, this is just ln absolute value x minus 3, and this one, it will be again ln 1 plus 2x, and because there is 2 in front of x, I need to divide by 2. So I will just divide by 2. And that's how we do the integration if we know the partial fraction. Thank you, and we will do another example from the first set of questions.